Hey everybody, my name is Mohit and I welcome you to my YouTube channel. I hope you all are doing great. In this video, we are going to discuss an interview question on binary search tree where ask is to implement a logic for tree traversal using BFS, also known as breadth first search. Okay, so let us understand this problem statement in detail. Okay, so before we start our discussion on problem statement, I hope you guys must be aware about how the node of a tree look like and what are the different property it consists of. But still, for those who don't know, I will quickly recap. So if you have been following my previous videos, by now you must be knowing that in case of doubly linked list, we have a node with next and previous pointer, right? So similarly in case of binary search tree, again we will have similar node with its value and left pointer and right pointer. Okay, so any new node, if we want to insert, it can either go to left pointer or right pointer of this node based on these three conditions what we have mentioned here. So here node with value 1 will be considered as parent node and any node which is coming below it will be considered as child node. So child node must fulfill these three conditions. So first is if value is smaller than parent node value, then it should go in left of parent node. If value is greater than parent node value, then it should be connected with right pointer. And duplicates values are not allowed for valid binary tree. Okay, so for now we must keep these 3 points in mind in order to solve this problem in a much better way. So now let's say if we have 3 nodes, then each node will fulfill those 3 conditions. So for any node, if you check, left value should be less than its parent node value and the node present in the right side should be greater than parent node value. So here it is a small tree with only 3 nodes, so we can directly check 5 is less than 10, so it is in left side, and 13 is greater than 10, so it is in right side. And also there is no duplicate value, so it is a valid tree. Now let's say if we want to insert a new node with value 3, we must follow those 3 conditions. Okay, so first we will verify if this is a duplicate value or not. So currently we don't have any node with value 3, so it is a valid node and it can be inserted. Now we will compare value with its parent node. So starting from top, 3 is the new node value, so 3 is less than 10, so it will come in left side. But in left side we already have a node with value 5, so again we will compare. 3 is less than 5, right? So again we will go to left side. Now here we don't have any node, so this node with value 3 will be inserted here. Okay, so this is how the newly inserted node will look like, and this is how our total tree will look like. Okay, now coming to the problem statement. According to the question, we are given this tree and this is a valid binary tree, so each node must satisfy those 3 conditions. Okay, so left side of any node should have smaller value than its parent node and right side of any node should have greater value than its parent node, and there should be no duplicate value. Cool. So based on this given tree, we have to get output something like this. So output is nothing but a list consisting of this value. So if you see here, this is first level, this is second level, and this is third level. Okay, so first level 1 node value will come here, so 47 we can see here as a first value. Then coming to second level, starting from left to right, the value will be appended, so 21,76. This is what we can see as a second and third element. Now coming to third level, starting from left to right, 18, 27, 52, 82. So we can see these last 4 elements in same order. Okay, so this is the expected output, and this is also known as BFS, breadth first search, because we are traversing the node starting from top to bottom. Okay, now it's time to implement this logic, so let me switch to VS Code. Okay, and I have already imported required classes, class node and class binary search tree. So class node will have a constructor with required properties of node, and class binary tree will also have a constructor along with insert method. Okay, so what this method will do, basically it will insert any new node. So we have already seen example by what logic we can insert a new node in binary tree. So the same logic we have implemented here. You can go through this method, okay? But these methods will be used during testing. That's why I have imported this, okay? Now let us create our new logic, and I will name this function as traverse tree BFS. Okay. Now first we will check if tree exists or not. So I'll write if self.root is none. Let's say it is not there, then we will return none. Okay. Now for all other cases, what I will do, I'll create a temporary list and will insert root node as its first element. Okay. And I will also create a final list which will store the required output. Now I'll create a while loop till we have element in this temporary list. So currently we have one element self.root. So it will come inside this while loop. And then we will pop first element from this list. So currently first element is nothing but self.root only. So this node is currently holding root node. Now with this one, what I will do, first I will append this node value in our final list, and then I will check whether there is any child node for this particular node or not. So I'll check if node.left, then in this list we will append that particular node which is present in left side of this node. So basically we are appending child node which was present in left side of this node, okay? And if node has right child also, then again I will do same thing, will append its right child. Okay, so we will follow this while loop until we have node present in this list. Okay, and once it is done, then I will simply return this final list. Okay, so this is our complete logic for tree traversal using BFS. So I'm pretty sure that you might not have got any idea what this method is exactly doing. So don't worry, I will explain each and every line of this method using slide, and you can understand things in a much better way and you can connect these dots. Okay, so let us understand this method using slide. So this is the given tree, and we are creating a temporary list and storing self.root as its first node, and also we are creating a final list which is currently empty. Okay, so this is same what we have mentioned. We are storing self.root in temporary list which is 47. So this 47 is not a value, it is a node. Okay, and currently final list is empty. Now since this list has length 1, so it will come inside this while loop, and now it will pop first element from this list. So you must be knowing that from a given list, if we pop first value, then it will remove that first element from the list and will return first value, right? Okay, so before iteration 1, temp is this, final list is this, right? Now let's start iteration 1. So for first line, pop first from temporary list. So in temporary list currently we have only one node which is 47. Node will have 47, okay? And since we have applied pop, so it will remove this node from temporary list, and now this temp list will become empty at first line. Okay, so at first line two things are happening. We are assigning value to this variable, and also the node element is getting removed from this list. Okay, now coming to second line, we will append the value of this node in final list. So this value will be appended in final list. So currently the final list was empty. Now we will append this value, so it will have 47 value as a first element. Okay, now this will check whether 47 has any left child or not. If yes, then it will append that left child node in temporary list, and similarly it will check for right child. Okay, So for 47 we have left child as well as right child, correct? Left child is 21, right child is 76. So we will append these two values in temporary list. So now this list has two node 21, 76. So at the end of iteration 1 we have temp equal 21, 76, and these two are nodes, and final list has value 47. Okay. So if you go to next slide, focus on this left part. This is the new temp and new final list after iteration 1. Now it will again check this while loop condition. So length of this temporary list is 2. So it will come inside this while loop. So again pop first from this list. So first element of this temp list is 21. So node with 21 value will assign to this node. So node will be equal to 21, and parallelly it will be removed from this temp list. Now only 76 will be there in this temporary list. Okay. For second line, it will append its value in final list. So earlier final list was this. Now new final list will be 47, 21. So 21 will be appended. Now again it will check if 21 has any left child. If yes, it will append that left child node, and then it will check if 21 has any right child. It will append right child node to this list. Okay. So if you check this tree, 21 has both left child and right child. So these two will be appended in this temp. So 76 was already present, and now it will append other two nodes which are left child and right child. Okay. So 18, 27. So at the end of iteration 2, this is the new final list and temporary list. Okay. So if we go to next slide, focus on this left side. This is the temporary list and final list after iteration 2. Now again we will check this while loop. So this length is greater than 0. It will come inside this while loop. Will pop first element from this temporary list. So first element is 76. Here you can see 76. So node equals 76, and it will be removed from the temporary list. So remaining node will be 18, 27 at the end of first line. Now it will append this node value to final list. So this 76 will be appended to final list, and the new final list will be this one. Okay. And then again for this particular node, it will check whether it has left child or not. If yes, then it will append, and then it will check whether it has right child or not. If yes, it will append to temporary list. So node is 76. So if we go to this node, it has left child as well as right child. Okay. So these two nodes will be appended in temporary list. That's what we are observing here. 52 and 82 has been appended. So at the end of iteration 3, this temporary list and final list will look something like this. Okay. So moving to next slide, focus on this one, left part. So at the end of iteration 3, these are the new temporary list and final list. So again we have element in this list. So it will come inside this while loop. We will execute this first line. So pop first from this list. So first element is 18. So node equals 18, and it will be removed from temporary list, and it will append its value in final list. So 18 will be appended in final list. So new final list will look like this, and for node 18 it will check whether we have left child using this condition. If yes, then it will append that node. So if we go to node 18, this left pointer is pointing to none. So there is no child present in left side. So it will skip this if condition. It will check if it has right child or not. So again there is no right child. So it will again skip this if condition. So at the end of this iteration 4, we have this as a temporary list and this as a final list. Okay. Now coming to iteration 5. So at the end of iteration 4, the new list will look like this. So we have element in temporary list. So it will again come inside this while loop, pop first element from this list. So 27 is the first element. So node equals 27, and parallelly it will be removed from this list, and then it will append this value to final list. So 27 has been appended to this list, and again 27 has no left and right child. So it will skip these two conditions. So at the end of iteration 5, this is the new temporary list and final list. Okay. So we will go to iteration 6. So temporary list have value 52, 82. So length is 2. So it will again come inside this while loop, pop first from this temporary list. So 52 is the first node in this list. So node equals 52, and parallelly it will be removed from this temporary list, and it will append this value to final list. So 52 is appended to this final list, and again if you check node with value 52, left and right child is none. There is no left and right child, right? So again it will skip these two conditions, and this is the final list and temporary list after iteration 6. Okay, so in temporary list we have one node still there, which is 82. So we'll start iteration 7 because this length is still 1, so it will come inside this while loop. So pop first from this list. So in temp we have node 82, so node equals 82, and parallelly it will be removed from temporary list. So now temporary list will be empty, and it will append this value in final list. So 82 will be appended in final list, and now it will again check these two conditions. So if you see this node with value 82, it has neither left child nor right child, both are none, right? So it will skip these two conditions, and at the end of iteration 7, this is the final list, and this is the new temporary list with no node. So now length of this temporary list is 0. So after iteration 7, this condition is false, so it will come outside of this while loop, and it will simply return this final list. So the expectation is this final list should have the same value what was expected. So let us check. So if we see this final list 47, 21, 76. So 47 is at level 1, 21, 76 is at level 2, and 18, 27, 52 and 82 are at level 3. So it is in same sequence what was expected. So we have got this output using BFS. Okay. So this is how our output looks like. So now I assume that you must have got a very clear picture what is exactly happening in that function. Okay. Now let us test our method in order to check whether it is working correctly or not. Okay, so first what I will do, I will create instance of this class binary search tree, and then I will insert these nodes. So during insert, it will consider those three conditions, and it will create a valid binary tree. So now let me call our method which we have just created, traverse tree BFS, and let me run this code. Okay, so it has not returned. Okay, so I missed print statement. So basically I need to print this value, right? Now let me run. Great. So if you see this output, this is exactly matching with what was expected. Okay. Okay guys, so we have successfully implemented BFS for tree traversal, and we have discussed the method in a very great detail how the things are happening, and I hope you must have got very clear picture of it. Okay. So that's it for this video. Thank you so much for watching. We will meet in our next video with a practical and potential interview question. So please stay tuned. Till then, take care and goodbye.